Good morning, everyone. We're here to discuss about the DINRSM RS485 version. In this video, I will show you a quick demo on how coupling the device to a Modbus automaton and get some programmation configuration on it. But first of all, I will invite you to download our user guide on our ATIM website. To do that, please log in your browser into the www.atim.com and make sure to select the French version because this one is up to date and we're still working on our English version. Afterwards, please select the product window and the ACW product line, then the ACW DINRSM. In this page, you'll be able to see the main description, technical characteristics, and the documentations about the DINRSM. You'll be able to download then the version 2.4. In this video, we'll be coupling a DINRSM connected to the LoRaWAN network with a Modbus automaton. The power supply of the DINRSM is actually visible on the right down corner with the black and red cables, which deal with the ground and 10/30 volts entries. The connection between the DINRSM and the Modbus automaton is made through RS485 connection. The entries of the DINRSM are TX and RX, respectively, connected to the 24 and 23 entries of the Modbus automaton. The power supply of the Modbus automaton is visible on the down right corner on the 13 and 14 entries. On the other side of the Modbus automaton, you can see 6 different entries. Entries 9 and 10 deals with phase A, entries 7 and 8 deal with phase B, and 5 and 6 with phase C. In this video, we'll be centered in phase A, entries 9 and 10. So after you reach this proper configuration between the DINRSM and the Modbus automaton, you should connect the micro USB from the DINRSM directly to your computer. You'll also need the ATIM Cloud Wireless Configurator program executable. You can either have already downloaded it or you can download it from our website. We'll show you the way how to get it in the comments of this video. By default, the ATIM Cloud Wireless Configurators appears like that, but when you connect the DINRSM to your computer, you'll get into the DINRSM page automatically. You can see here that our already created a radio header. We'll be deleting it all and also setting the default parameters in order to start from 0. On the left side, you can see that we have several parameters to configure. The serial parameters, the RS type, the baud rates, the parity, the data bytes, the stop bytes, and then other parameters. Here, the RS type is set by default on RS485, and it's okay because that's the configuration and the connection we are looking for, and by default, it's that one. Regarding the baud rates, that information is normally given by the manufacturer. In our case, when we bought the Modbus automaton, we got an Excel with all the technical information about that device. And here we'll be opening the Excel in order to get that info. Here we can see that the baud rate is supposed to be 9600 bytes per second. So we set that parameter. And we look for the parity parameter, which is even in the Excel. So we set even on the configurator. And regarding the data bytes, it's supposed to be 8 bytes. So we look at the Excel and it's okay. And the stop bit is 1 stop byte. So we just have a quick check and it's the same. So we can validate that part. Regarding the other parameters, we have the statement period, the keep alive period, the time at Modbus, and the pairing method. The statement period will be the period at which the DINRSM will be sending through the LoRaWAN network a frame of containing the information of the Modbus slave when the micro USB is not connected. The keep alive period will give you main information about the DINRSM, for example, the battery life, and every other parameters are working without any issues. Regarding the timeout Modbus, in this case, it's set at 1 second. This timeout period of time deals with the period when the DINRSM, which is a master, will be asking the slave, so the Modbus automaton, for an information. If after if the slave doesn't give back the information to the master after 1 second, then there will be an error frame, an error message, and we'll have maybe to change that timeout Modbus. But normally and by default, that timeout is okay. Regarding the pairing method, by default, it's over the activation.
After you get the correct configuration of both serial and other parameters, you'll be able to create a Modbus frame. To do that, you either right click and click on Add Network and Modbus Frame, or you click on the Add button. By doing that, you'll see a Modbus Frame window open, and you first have to enter the radio header. The radio header is in this case 1. Regarding the function code, you'll have to check the Excel provided by the manufacturer and look at the common column. In this case, you see that it's 03 in hexa, and in this case, it's already by default in 03, so it's okay. The device number is available on the Modbus automaton, so you just have to check out the proper device, and you see in this case that is 12, so you just enter 12, no hexa. Regarding the register, you have to check out the Excel table again and check out the parameter you want to analyze. In this case, will be interesting in phase A current, and in hexa, that corresponding value here, and that register deals with 100C. So you just make sure to select hexa and enter 100C. For the last parameter, the quantity of holding register, you have to also check the Excel because it's a default value. In this case, it's 2. So you make sure to select 2 and you click on OK. After that, you apply to ACW, you save the configuration and right click to test and debug the radio header. In this case, you can see the TX and the RX, the emission and reception frame. So everything looks to be okay. In this case, everything is fine. We have the value here, 12C. So we check out the Excel table again, and we see that that value is in milliamperes. So we can open the calculator in order to get the conversion from hexa to decimal. And remember that the value is in milliamperes. So you just open the calculator, you enter 12C, you make sure you are in the programmer code and mode. You select decimal, and you can see that we have 300 decimal, which deals with 300 milliamperes. That's the amount of intensity we get. Now we'll be creating another frame in the same radio header, and also we'll create a new radio header in order to show you the main differences and also what it implies at the moment to visualize the data on the platform. So in order to add a Modbus frame in the same radio header, you first click on the radio header here, number 1, and you right click and click on Add Modbus Frame. You'll see that the radio header is fixed at 1, which is logic because we are already working in that header. We are in the device number, it's obviously the same here. We're still working with the same automaton, so it's 12. Regarding the function code, it's still 03 because here the common column is 03 for every function, so it's okay. Regarding the register, here will be interesting. In this case, for example, phase A active power. In this case, the data address, we see that it's in hexa 6002, so we enter that value. And regarding the quantity of register, we also check that line on the Excel and we see that the longitude is 2. So let's write down 2 and click on OK. You can save the modification and click on apply to ACW and test it. In this case, we can see that we have no active power, which is logic because in that configuration, we do not have any amount of that value. So that's good. Now let's add a new radio header. It would be the radio header number 2. So you click on add and you enter the radio header number. In this case, it will be 2. The function codes will be the same as well as the device number 12. Regarding the register, we'll have to select a new data address, and now will be interesting, let's say, in the total active energy, for example, which is the total active energy and deals with 7000 in hexa. So make sure to enter that value as a register and check out the quantity of holding register, which is in this case 2 also. So we apply modifications again and test that frame. In this case, we also get a value of 0, which is current in this case. After getting the configuration done of the 2 radio headers, we'll get to the platform in order to show you how we can get the visualization of the data frames and the messages. But just before that, please remember that radio header number 1 is composed by 2 registers and that radio header number 2 is composed by only 1 register. Radio header number 1 is composed by register 4108 and also register 24578, sorry. Both registers deals with respectively phase A current and phase A active power. Regarding radio header number 2, the register is this one and deals with, if remember well, the total active energy. Okay, so that's perfect. Now please log into the acw.atim.com platform webpage. Actually, we'll using that demo our platform, but if you have your own platform, you should be able to do the same on yours. You also have to make sure to disconnect your micro USB in order to receive the frames and the values. In this case, you can see that I already received 2 frames because I had disconnected the micro USB for some time. But now we'll start from 0 and I'll show you all the steps, repeat all the steps in order to make you understand the whole process. Here you just have to disconnect the micro USB and you click on the big button. You press that button and you'll see that you'll receive a new frame. That frame is actually pretty quick because you have 0 delay, and that frame is composed by actually 2 messages. You can see here that the radio header is on here, 1, and then you have 2 messages, 1 here and the other one here. Because you have to remember that in the first header we had 2 different data and registers, and the first one was dealing with phase A current and the second one was dealing with phase A active power. And afterwards, you are supposed to receive also another frame dealing with the register header number 2 or the radio header number 2, and it contains also only one register and was dealing with the total active energy. So here you get the value on the platform. Now that we have already disconnected the micro USB, we'll have to wait for 10 minutes corresponding with the statement period in order to receive the remote and automatic frames. About 10 minutes after, we received 2 new frames. We can see that regarding the first radio header, the first register value is actually new and it's C8 in comparison with the previous value we got before 12C, but the second register still remains the same. So let's check out what C8 in decimal. In hexa it's C8 and in decimals it's 200. Which is actually 200 milliamperes because that register was dealing with the phase A current, and C8 is so 200 milliamperes. The second register was dealing with the phase A active power. And regarding the second radio header, we have and still have the value of 0, and that register was dealing with the total active energy. So we have the information that that value is still 0 and still remains the same. Here we can see and visualize all the information that we got remotely through the LoRaWAN network and thanks to our DINRSM. In this configuration, we only used one automaton, which is a slave automaton. You connect the DINRSM, which interacts as a master on that slave and requests the information and sends it remotely. Just to sum up, for this demo, we used a DINRSM working on the LoRaWAN network and coupled to the computer and the configurator through a micro USB. The DINRSM was coupled with a Modbus automaton, and you can actually see that value, the final value is actually 300 milliamperes. We encourage you to subscribe to our newsletter for further information and to our YouTube channel. Thank you very much for watching. Bye-bye.